So let's start with what is VCS or version control system. Okay. So what is it basically? Now, several times you must have noticed whether we are working on a Word file or an Excel file, we would often want to undo some of the changes or go back to some previous versions. And luckily, in the modern versions of the Office suite, MS Office suite, you have a version control built in where you can clearly see all the commits and who different by different people. And basically, you can switch back to any version. But again, it is okay for only little things like that. But when we come to controlling code, controlling different versions of the project, we need something much better than that. So we need something far more robust with more options, with more traceability. So this is basically version control is how we control the uh, changes to software and track who's changing and where they're changing and why they're changing. And if you want to go back to any specific version, we can always go back to it. Version control system is shortly called as VCS. Okay. So even though what I show right now will be all based on Java project, a simple Java project, the same thing can be applied to any project, irrespective of what tool you're using, what technology you're using. This basically works on files, not just projects. You can even control a single file or any amount of file without even, you don't even have to have a project for that. You can just have a simple directory in your computer and you can go ahead and control that as well. Okay. So the what part is there and the why part, if you see, yes, manually tracking it is not only difficult, but it also becomes not practical after a point of time. Maybe when the file is small and what you're doing is also limited and there are limited number of people working on it, you could keep track of it. But of late, we've seen even with limited work and limited people working, over a period of time, even small changes and small files become difficult to manage without a version control. In the sense, you'll not really know how to go back to a specific version or what exactly was changed in version X compared to version Y. So it becomes really cumbersome. So that is why we need a strong version control system. Okay. So let's look at the how part. So basically, let me come here. See, there are three ways of having a version control system. Okay. Irrespective of what, we are still not talked about any specific uh, type of version control system. Remember, we want to talk about, uh, see, I'm just so far talking in general, but all those things apply to, we will be discussing, we will be basing our discussion on Git. It's a very, very popular version control. You'll see that there are several of them actually. So before we see some examples as to what kind of version controls are present or what different brands are present, um, you will have to know certain basics of version control. In the sense, they can even be local, or they can be central, or they can be distributed. What does it mean? On a local version control system, all the files are just stored on your local computer only, meaning the version tracking, the change tracking, everything is only on your computer. So why would you want to do that? Well, you are working on a set of project on your own, or you are working on a set of files on your own. You might be doing that. I believe now this is one of the oldest forms of version control called, and there is a specific product called RCS. Just like Git, you have RCS. which is still being used. That's what I got to know. But local version control are, you know, only you are working on it, and it is very difficult to collaborate with others. And it could also be a single point of failure, like something happens to your hard drive, or off late you have all kind of fancy things happening. It could be a physical damage or a software related damage. So anything that happens, you lose. You have version tracking, all right, but you might lose the entire project. Apart from not being able to collaborate with your friends, you will be losing. You have a chances of losing the entire project. So local file system are not popular at all. So these this RCS and things like that, they were in use several years back. Maybe now only some specific use cases are there for them, but otherwise it's very unlikely that somebody will be using it. Central version control system was very popular. It still is to some extent, although Git is taking up all the limelight. There are a lot of projects which are still using central version control. So, like the very name suggests, all the files are stored centrally on one computer dedicated as a server, and all other developers or any other users of the file being connected to that server. So whenever they want to access and make some changes, they get the files from the server, make the changes, and then again put it back onto the server. CVS, TFS, these are all specific brands actually. So TFS is from Microsoft, Team Foundation Server. In fact, now it has been rebranded as VSTS. You don't have to worry about these names, but it doesn't hurt to just to get to know them. VSTS stands for like Visual Studio Team Server. So they've been some they are doing some rebranding, but otherwise Team Foundation Server was very popular and it is still being used. It's a centralized version control system. People were quite happy with it for a long time, even though there were some cons. Now, almost any system you take, there will always be cons, pros. The cons of the central cons were this: like whatever happened locally, okay, the same thing can also happen to the server. If all the files, now all the projects are being stored on one central system, and if at all it fails for some reason, then you have a central point of failure, meaning none of the developers or none of the users of the file will be able to proceed with their work. Of course, they used to mitigate that, by saying that we anyway have a local uh, version also. But what if nobody has some latest changes? Okay, and centralized version control system were very slower and heavier, not just because of network latency and other things. Network latency and related management was done much better, probably 2010 and later. That could not be a real cause, but rather they use a different mechanism. They use a different mechanism of maintaining different snapshots of the project. Sometimes, when you make a different copy of the project, the entire project is copied to a different point. So it tends to be heavier, slower. But since Git was not really popular back then, and uh, it was, I could say Git was still in development at this point of time, TFS was the only choice, and people were pretty happy with that. Even though it meant you need to be online in order to talk to the server, and even if the server failed, all the developers had to wait until we somehow recovered the files from some other backup probably and nominated one more server. They were happy with it, and moreover, everything they did related to version control was by talking to this server. For each and every simple and small action, they had to talk to the server. No decisions or no actions could take place locally. You don't have to really worry about the too much details of to why this happened, but eventually when you start looking at a distributed version control and you start looking at Git, you will understand what all this means. So bottom line, even though this was popular, this had a couple of shortcomings as well. But I have not mentioned one great advantage here. Of course, we also started working on TFS itself, or CVS. Or whether it is Subversion or whatever it is, we started working on a centralized version control back in 2008 and 9 because that was the default standard back then, since Git was not very popular. One major advantage of centralized version control, if at all you can call it an advantage, is that it is slightly easier for beginners or newcomers into the IT space to understand it. And in fact, even after Git became popular, people were still a little hesitant to switch to Git because they actually felt it's slightly more complex, or rather unnecessarily complex, compared to a centralized version control. But eventually, uh, people figured out that that slight amount of complexity and learning curve involved in learning and gearing up with a distributed version control does pay off in not just the long run. Even once you move beyond the basics and once you just get your firm footing on the basic concepts, it'll start paying you off pretty well compared to a centralized version control. And eventually, I think people just accepted that Git is not only just superior. Once you probably get the basics right, it is also easier to learn. It is only when you do a relative comparison between central and something like a TFS and Git that you find Git is slightly complex. But otherwise, it is not really hard if you get the basics right. So that is what we are actually planning to. We are trying to get the basics right, and I want you all to be with this on this, pay maximum attention to this. Again, I know I've already stressed this point, but I'm doing it again. This is very important topic, and also this is the topic which is this is one area where newcomers find it difficult to get hold of as soon as they get into projects, and because of that also, mm, there can be certain issues in getting them on board. We've seen that happen. So that is the reason I would want to go slightly slow here until you've got some basics right. I hope yeah. All right then. So let's look into how distributed version control manages this. So we'll come here. Let me move this slightly back here. So this distributed version control is like the best of both the worlds. And what it does is all our files, let's say there are 10 people working on a project. Let's say it is a Java project only. Okay, let's say it's a core Java project and there are 10 software engineers working on it. So apart from having one central server, which stores all the version history of all the files, all these 10 guys also store them locally. So the local, if I can call the current state of your project as a snapshot. So the local snapshot is pretty much a clone, a copy of what is there on central. And whenever you do some changes, you all do it locally. That is why it is super fast. All changes you do it locally, and eventually you just push on the sum of all the changes back to the server. Not SOME sum, SUM sum. The sum of all changes you push back to the server. We will see this happen through the application. I really want to show this to you in application. That is the reason I'm not really keen on slides. With a given amount of time, it's not about mastering all the concepts there, but getting a head start to all the application aspects of it. But nevertheless, you just have to know that in a distributed version control system, both local and um, say centralized copies are maintained all the time. So this gives us a huge advantage in that even if the server dies, no issues. All of us have the complete history of who's changed which file, why they have changed, and how to switch back. Everybody keeps maintaining. I can give a very vague analogy to blockchain. You must have heard all these days that bit something like bitcoins And overall, blockchain technology has taken up the IT world by storm. People are not just using it for bitcoins; they're also using it for many other aspects of that is a kind of a distributed technology only. It's distributed ledger system, what we call in a blockchain. So Git is very roughly comparable to that in the aspect of maintaining all the transactions on local as well as servers. So everybody is aware of what's happening. Even if one computer dies, which we call as a server, some other system on the network can be immediately converted into a server. Not And that is only one part of the story. The biggest, if you ask me, the biggest reason for people adopting Git is these two. So I've just put a flag on those. You can work offline to a large extent, and most important of them all, it is super fast and super light. You will see that because the Git uses a completely different approach of maintaining different file versions. Rather than copy pasting the whole project, it does it in a different mechanism. Now, I would probably give you all some links to understand how Git is actually designed. Okay, but it is beyond the discussion of this topic, and I'll only be touching upon those aspects which are required for our application aspect. But there are a lot of things beyond that as well. So I'll give you some material so you can look into it. So it came back in 2005 actually, and Linux, the community which maintains Linux, was also responsible for Git being so popular because they wanted to use this to maintain the Linux operating system source code itself. You can imagine the source code of an operating system. It would definitely be large. It is one of the largest projects, and you can also imagine the amount of transactions it happens because there are too many people involved in keeping this project alive. Too many developers alive. Too many developers want to keep it alive in and contributing to them. So they wanted to have a solid version control system. They were using a different one before, but then the company, their partnership with that company broke off, and they were forced to find out a solution on their own. And Git was a result of that. And Git is also open source and it is also free to use. There are some companies who probably take Git and you know start releasing their own flavors, and this is something expected for all open source products out there. People might take up the open source project, and if at all they really want to tweak it, they tweak it and release their own flavors of that particular product. And yeah, it is entirely community driven. It is fast and light, not just for small projects or a single developer. It can be for even tens or even hundreds of developers. So it has pretty much become a default standard of late in the past 6 to 7 years, if you ask me. It has pretty much become a default standard of version control. You might see different vendors out there, but they all be using it only. So what do I mean by different vendors? Like I said, since it's open source, you'll have Git provided by different companies, and they will brand it for their own use. They might not charge you to use it as such, but they might make it a part of a bigger ecosystem, and they might charge you for using the bigger ecosystem and not just the version control in itself. Mercurial, Bazaar, and there is also GitLab. You will find different flavors of this. Okay, so in fact, I have also included those in the tools section. I'll come to that, some of the different flavors out there. So this was about the um, so what is the takeaway from all these things? The takeaway from this how part of the VCS concepts is that we can either do version control management local, central, or distributed. And currently distributed is the most popular, and among them, Git is almost the default standard. Okay, and it is super fast and super light. We will see how it is actually. So that's about it. Let's also see the where part. Yeah. So I intentionally added this node so that you people understand what do you mean between the difference of Git versus GitHub. Most often, I'm sure you might have heard these terminologies, but you'll have to clearly know what is what and what are all these Bitbucket and GitLab. So remember, basically, you can put a Git. The Git is also an application. It's like a software for version control. You can, if you really want to use it, your company can decide or will decide where to put it. If they do not want to use a public server, sometimes these companies have a confidentiality agreement with their client and customers saying that their source code will not be out there on public domain for various reasons, security, confidentiality, whatever. So in those cases, software developing companies or service providers, they might want to put up Git on their own on-premise server. So it will not be accessed by www.somewebsite.com, or even if it is accessed, it will be only within the company on their own intranet or on their own virtual private networks. So you can install Git on a local server also and start running it without depending on any of these public servers. Some companies just want to off late keep all their infrastructure requirements low, whether it is version control or whether it is testing. Some people even go to an extent of renting out an entire computer as a virtual computer, which will be running elsewhere. So they'll be just accessing it with their thin client, whether it is database server, whether it is version control server, or whether it's a SharePoint server or whatever it is. Some companies just want to, take this on a rental basis. Everything is online. So it inevitably has to be a public server. But of course, there will always be strong arrangements of security as configured such that there'll be least risk of exposing the company's intellectual property, source code included, from being accessed by actual public or somebody without any proper security mechanism. So those things will be taken care of. So when Git is being hosted on a public server, you get several options here. Now, I have listed only four. I'm sure there are many more. GitHub is one popular public server. Now, they offer most of the things for free, and I believe paid stuff, they'll give you much more than that. So there are some computations for GitHub, including Azure repos. Now, this is from Microsoft. Again, a lot of it is free, some of it is chargeable. Bitbucket, we will be using this. GitLab, again, a very popular company. They not just have this version control system, but it is this VCS is a part of a larger offering called DevOps, where they give end-to-end infrastructure for software delivery or the software delivery life cycle. Nevertheless, GitHub is still quite popular. It initially was owned by somebody else, and now it is owned by Microsoft too. Azure Repos is one of their, under the Azure umbrella of offerings. And I am planning to use Bitbucket because somehow my experience with GitHub security, especially creating tokens and logins, is a little cumbersome, especially for such demos. Nevertheless, whatever you learned for Bitbucket, the same 100% same applies for GitHub also, because they both are based on Git. The underlying software they use is Git itself. So whether I use company A or company B or company C or D, it is just a matter of choice based on several other aspects. But when it comes to the Git commands and the flow and the concepts, it is 100% same, irrespective of which server you are actually putting your code onto. So that is the reason I also just wanted to make sure that you know where we can actually host Git. In fact, if you are one person using this software, or whatever source control which you want, you don't have anybody contributing to it, and you are okay if you don't want to make a backup of it online or whatever, you just okay with, you can just put it simply on your own computer also. Nothing will stop you. You actually don't need a server at all, unless you are planning to what do you call, collaborate with other developers, and you also feel backing it up on a server is much more safer, because in case locally something goes wrong, you also have a backup another place. So if you really go to that route, so let me add one more node here. You can just host it on your personal computer also. Okay, so nothing would stop you from doing that. You can put it on your local PC. You can have a Git server on a server or a public server. So what we will be doing for our demos is, first we will install Git on our PC only, and we will see. Let's forget about this local server route. We are not going that route. We will just put it on our PC. We will do some basic stuff, and eventually we will also decide to put this on a public server like Bitbucket. So we'll start with a PC, we will do some learnings there, and we will eventually see how to put it on Bitbucket. Because remember, we are all we would definitely get into a situation where we will work with a large team in a large organization. So learning it only on a PC does not serve the purpose here, but putting it on a public server is probably a couple of things extra. That's it. It all starts with PC. You do a set of you execute certain commands and make sure that the version control is all happening locally, and then you eventually push them all to a public server. So it is a one or two extra steps. So we will see that also. All right. Any questions so far? You can interrupt me at any point if you have any questions. So let's and at this point, see, I've just told you about the server aspect. Like there are different vendors out there, different companies. But even on the client side, so remember, the moment you see a server, somewhere you will also see a word called client. That they both coexist together. You have an application running on a server, you need some other mechanism or an application running on the client side in order to access this or deal with this server. So what are those? So let me take a look at that. So on the client side, so I can even call them as client tools, but that's okay. Mm, that's okay. We will leave it for now. We can look at the naming. So you can think of this as client tools. So I have two broad mechanism of, sorry, two broad types of tools there. One is a console based. You have just a terminal and you start issuing all kind of commands there. No graphical user interface at all, like menus and probably graphs, or no clicking, dragging, dropping, none of those things. It's all console based. And the other is graphical user interface based. Which one to use? Well, it depends actually. At one point of time, it would become a matter of choice. When you are learning something, you better based on my experience of using both. I think a console based application, even though it takes a little more time because of typing the commands, the it is still better in the learning aspects. And in fact, you can go ahead and use this even for projects. Nothing would stop you from using this out there in the projects. A lot of people still use this in spite of having several GUI based tools, for the reason that they don't have to remember various menus and options and buttons and things like that on a GUI. So they just remember the commands, irrespective of which company they work for, which project they work for, and what tools they have installed. Commands remain the same. So that is the biggest advantage. As long as it is a Git based tool, commands remain the same. In fact, in console based also, there are a lot of different tools out there. One is from the official Git It's called git bash instead of saying git prompt or git terminal or git shell or something like that. Remember, when you install Java, you got J shell. Similarly, when you install Python, you get a Python shell or a Python interpreter. So it is a very basic way of communicating with that software using commands. So in fact, it is, instead of saying console based, you can also call this as CLI, command line interface based. So this is a much more generic term. Command line interface, graphical user interface. So we will be using Git Bash, that is the official Git client, for talking with any of these guys, any of these guys. And there are other options also. I don't remember anyone as of now, but I do remember looking into some of them before. Some are some are much more better, some are not so good, but we'll just stick to the official part. I don't want to install too many softwares. What other options we have when it comes to GUI based? Now, when it comes to graphical user interface based, okay, the official one out there is a Git desktop. So if I just say Git in my system, so it also has, so if you see, they call it as Git GUI, but initially it used to be called as Git desktop. So maybe I'll just give the same name only, Git, Git GUI. So that is one option. So when you install Git, I'll show you how to install the most basic requirement. You get this out of the box. And if you want to go the integrated route, so if you see here in the Eclipse, if I again go to help, and if I go to this about Eclipse IDE, and if you see here, you have a small tree or a node kind of diagram here, which is actually Eclipse eGit. So if you click on it, it will show you some of the information about it. So what is this eGit? So if you see eGit, actually, it is one of the GUI based clients, but this time it is not offered as a standalone project. It is integrated into Eclipse itself. So a lot of people use this as well. I am somehow not very comfortable with that for a couple of reasons. I keep changing the editors based on what project or client I'm working for. So I'll have to remember several icons and buttons, which is too much for me. Second, I really did go ahead and actually try out using eGit a couple of times, but somehow maybe with the version of Eclipse I have, or I'm not sure what happened. Certain commands just were frozen. Eclipse stopped responding. So that could be a matter of getting a patch or getting a simple bug fix. But I thought anyway, and since I'm not really planning to go this route, I'll just leave it at that. Maybe you can, once you understood doing it in the command line interface, I think you'll be pretty much comfortable doing in any CLI or any GUI. In fact, people who learn directly GUI will feel it difficult to switch back to command, but not the other way around. Those who learn command line interface can easily adjust with any other graphical user interface. They just have to get to know where the options are hidden. That's all. This graphical user interface also provides a lot of other options, which is better to visualize at times. Maybe I'll show you to some other time, especially when there are too many branching and other versions installed. They will find it much more easier to visualize this. So it is only on a case-to-case basis. What other options we have apart from this eGit and Git official GUI? Several actually. I only listed three, but I'm sure there will be more than a dozen. And a lot of them are popular with different kind of projects and different kind of ecosystems. Of late, they all support all three platforms like Windows, Linux, and Mac OS. But still, developers have their own inclinations. Source Tree, Tortoise, and Sublime Merge, I think, are one of the other third-party GUI-based tools. Again, it'll once you learn one of them, it will be very similar to learn other. But nevertheless, this is not about whatever I'm planning to teach you is more about the basics of Git itself. So not I'm this will not be about any one specific tool. So this will be strongly Git basics. So with these, I now have to get into the installation aspect and then eventually into the Git flow. Okay, so we will see that shortly.